In a background, we've already learned that that's the standard form of the quadratic function. Okay, the last section we found zeros. We kind of limited to that. What we're going to look at, we haven't really looked at this yet, but this is the vertex form. Okay, so you can actually complete the square and you can put a quadratic function in its vertex form, then it assists you with the graphing. So we're going to focus a lot in this section on the graphing of a quadratic function. So one thing that you probably want to just pay attention to on this is these are transformations, okay? Like the k, that is up, down. Just think of it that way. And then how about the h? What does that do? Since it's inside the function, what did you learn on that? Yeah, that's left, right. So that h would be just kind of left, right. How about the a? Like if you did something like x squared and you put a number in front of the parabola, what does that do? Stretches it this way. And if you get that backwards in your mind, what it's doing is it's doubling the y values. That's what it's doing. Since it's doubling the y values, it makes the graph get bigger, therefore it stretches it. So that a is a vertical stretch or a shrink. Okay, like that, all right? So what we're going to look at first of all is just using this vertex formula and then doing the graphing. So a couple of things on here. The axis of symmetry, I'll show you as I graph this what that is. That just goes through what's called the vertex. The vertex is the point where the parabola comes together. That's symmetrical, that's your vertex. And then the other thing is the parabola can either open up or open down. We've already seen that. So if A is positive, then it opens up. And if A is negative, then it opens down. Okay? So what we're going to do on these examples below is they're already in the vertex form, so we're going to graph. And it turns out it's super easy to graph if they're already in the vertex form. That's what I want to show you. Okay? So we'll go down and look at a couple of these just to begin with then. All right, on this first example, first thing that you want to do, and this is really all you have to do, is just figure out that vertex. The vertex is right there. And don't get your signs backwards. The way I usually try to help students do this, that x minus 2 takes the graph where? Which way? If it's minus 2, which way? To the right. So see, that means the vertex is 2, not negative 2. What does the minus 4 do? Down 4. So that's negative 4. So be sure that you're careful about those signs. The one way to look at this is 2 minus 2 makes that 0. You're always kind of looking at what makes that part inside the parentheses 0. Okay, that's another way to think of it. Okay, now here's what you do. So you just go to that point. So you go ahead and go over 2, down 4, and that gives the vertex. Okay, and we're just going to get like 2 points on each side, but I'm going to teach you how to count this over so you don't have to calculate it all. So in this problem also, A is the number in front. In this case, A is 1. Since it's positive, that means the parabola opens up. Okay, so we know that for a fact. All right. Now, what you want to do is you want to just draw a vertical line right through the vertex. We call this the axis of symmetry because the parabola is going to be symmetrical about that. So we just say axis of symmetry. That equation is going to be x equals 2. It's always x equals whatever the x value of the vertex is. Okay. Now watch this carefully, and because this is the shortcut that I can teach you that'll keep you from having to do any arithmetic. If you have a vertex, you can draw this diagram if you want to. A lot of times students have never caught on to this. So if I go over 1, then I go up 1 to the second, which is 1. Okay, if I go from the vertex and I go over 2, then I go up 2 to the second. Why the second? Because that's what we're doing. It's quadratic. You're squaring. Then if you go over 3, what do you suspect you go up? 3 to the second, right? So it's like over 1 up 1, over 2 up 4, over 3 up 9. Okay? And if you learn that, that'll make the graphing real accurate and simple for you. So what you want to do, go to the vertex and just do this. Go over 1, up 1. That's your next point. Okay? go back to the vertex, go over 2, and then up 1, 2, 3, 4. And that's good enough. You can also go 3 and 9 if you want to. And then that gives the right side of that parabola. Okay, then you just do it the other way. So it's symmetrical. So left 1, up 1. Left 2, up 4. And then you've got a very accurate graph like that. Does that make sense? Okay. Now see, that's going to change if you put a number, like if you put a 2 in front of that, then you would go over 1 up 2 times 1, or you go over 2 up 2 times 4, and so forth. So it goes like that. So that's kind of a nice shortcut to learn. Okay, so that's how you do your graph if it's in vertex form. Okay. Okay, next one. Look at the graph. Tell me what the vertex is, just in your head. Negative 3, 2, right. Okay, it goes to the left 3. So that's going to the left 3, and then that 2 is taking you up 2. Those are the transformations, so it's good to make that connection. So you would have negative 3, 2. Be sure to get those signs right. So you want to go ahead and graph those points then. So that would be left 3, up 2, like that. How about the axis of symmetry? What's that? That's the one that goes like this. So what's the equation? That's what I'm asking. X equals negative 3, right. Okay. Remember, if you have a vertical line, it just goes through the x value. It's x equals whatever it goes through. Okay. So you would end up having the axis of symmetry like that. Okay. All right. Now, tell me if this parabola opens up or down? Down. How do you know? There's a negative in front. Okay, see that is a negative 1, so that A is negative 1, so it just means we're gonna open down. Okay, and then you still do the same thing. To get your points, what you can do is go to the vertex and just go over 1, but now you would go down 1. Then you would go over 2 and then down 1, 2, 3, 4. That's good enough. If you get 2 points on either side of the vertex, you're good. And then, of course, it's symmetrical. So then you've got your graph like that. That's a good, accurate graph. Okay? That's how you want to do that. All right? Piece of cake. Any question? Okay. All right. So when it's in the vertex form, the vertex is staring you right in the face. You can tell if it opens up or down. Then you can do that over 1, up 1, over 2, up 4, and so forth like that. To catch on to that, it's easy. Okay? All right. So I'm going to show you something else. We'll look at this a little bit later, but the vertex can be found 2 ways. You can either complete the square and put your quadratic in the vertex form, or you can use this formula, which I'll show you a little bit later in this handout here. Okay? I'm not going to do that yet, but that negative b over 2a, that just comes from the quadratic formula. Okay, you have all over 2a in that quadratic formula, so that's where that comes from. Okay, so on this next page, I'm going to show you 2 techniques on how to do these problems. Okay, I think most of the time you're probably going to prefer to do the vertex formula, but I want to go over completing the square. So what we're doing on each of these problems is we're going to try to put this in the form ax minus h squared plus k. You don't need to write that down, but you certainly can if you want to. And again, the vertex is always just h comma k. All right, so this particular problem number 2, it's not in the vertex form, so what I have to do is I have to put it in there. Okay, so let's go and let's just write down the problem. So we have f of x equals x squared minus 4x. So we're going to complete the square. So the thing is, you always got to make sure there's nothing in front of x squared. Okay, so we're good there. If there was a 2, you would have to factor a 2 out on this. Okay, so then what we do is we look at this number, and this is kind of what we've been doing here, is you take that negative 4, remember you do 2 things with it. You take half of it to get negative 2, then what do? And you square it, right, okay? So you get a positive 4. You'll always end up with a positive number there. So it's half of that middle term square. Now what you have to do on this is you put a plus 4 there. How do I keep from changing the problem? Add 4 on the other side. Okay, So I'm going to go ahead and, oops, hold on. No, teacher. Do this. I'm thinking of something else. What you want to do is you want to put a -4 there. And I'll explain that in just a minute why I'm doing that. I mean, that doesn't change the problem. The thing is, the left side needs to just say f of x. That's all it needs to say. Everything needs to be on the right side. So you add 4, subtract 4. That way you're not changing the problem. Okay? Now here's why. So if you go through and put parentheses around that, then that part will factor, and the -4 will end up just being the down 4 thing. Okay? So what we do is we go ahead and we factor this. Okay, so if you factor this trinomial, you would have x and x. You would have 2 and 2 to get 4. And then you'd have 2 minus signs. And by the way, the factoring, there's no guesswork to it. See, the -2, when you took half of that 4, that gave you what that factor was going to be anyway. It always will. And then the -4 just comes straight down. All right, so what you would end up having then is you would have f of x equals x minus 2 to the second minus 4. So that is the vertex form. Okay, does everybody follow what I did there okay? The only thing that's different on this is you're adding 4, subtracting 4 on the same side because you want that left-hand side to just say f of x. That's why I did that. That's different than the last section. Okay, now can you all look at this and tell me what the vertex is? Just in your head, boom, boom. 2, -4, good. Okay, so see, that's the benefit of that is you now know that's 2, -4. What are the transformations? What does that 2 do? How does that change the basic parabola? Right 2, what does the -4 do? Down 4, okay? So the transformations are just right 2, down 4. That's what the vertex is it's just showing you where that transformation, okay? How about the axis of symmetry? What's that? X equals 2, okay? That's just, the x value that it goes through, okay? And then the rest of it, we're ready to graph, okay? So just do the same things I showed you in the previous problem. So you go over 2, down 4. You put your axis of symmetry through there. And then the thing on this is A is 1. I haven't done an example yet where A is not 1, but I'll get to that in just a few minutes. If A is 1, it's easy. Over 1, up 1, over 2, up 4, over 3, up 9, and so forth. Okay? So you do that, then you got a good graph. So over 1, up 1, over 2, up 4, and then you just reflect those points because they're symmetric about the axis of symmetry. That's why we call it axis of symmetry. That's it. Okay? Does that make sense? Shake your head or something. Okay? All right? Okay, this is one method. I'm going to show you 2 methods. I think there's benefit in learning to do it this way. I find students generally don't like to complete the square. They like to use the vertex formula that I'm going to show you in a little bit. Okay, so let's do this on this number 3. Now this one's got a negative in front of x squared. Since it has a negative, what is that going to tell you about the parabola? It's going to go down. Okay, we know that. All right. So what we do is the same thing. Now what I want you to do on this is put a parenthesis around just those 2 terms and leave the -9 out kind of beside like that. Because ultimately we want to have x minus something squared plus or minus something. We're going with that. Now what you have to do on this is you have to factor this thing out. So that's like a -1. That has to be factored out. Okay? So when you do this, the next step you would say is take the negative out, and all that would do is change the sign. So we would have x squared minus 12x. Then I'll leave a little gap for my completing the square. Okay, always when you factor, check. So I'm just taking the negative out, that changes the signs. Okay, now the next step is where you have to watch super careful. All right, so here's what we're going to do. We're going to look at this middle term, and the same thing we've been doing. We take half of that number to get -6, right? Then what do you do with that -6? You square it to get plus 36. Okay? All right, now what I'm going to do here is I'm going to put a plus 36 there. Now watch this real carefully. This is where students mess up on this problem all the time. Okay, remember on the last problem I did plus and minus. I did plus 4, minus 4. So what do you think I do there? You think plus 36 or minus? What did I really add? I didn't add 36. What did I really add? Negative 36, right? See, that negative is making that negative 36. So I got to add 36 there. That's where students slip up. It's not plus 36 I introduced, it's minus 36. Does that make sense? Okay, so you got to add 36. If you subtracted 36, you've totally changed the problem. So you have to pay attention when you do that. See, the 36s cross out, don't they? Okay, does that make sense? Okay. All right, now what we want to do is we're ready to factor. So the negative comes down. And then what we would have from here is you would have x and x. You'd have 6 and 6 to get 36. And then you'd have two minus signs. Okay, remember I said that factoring always comes from that middle term that you took half of. Okay, so it goes like that. And then if you add that together, you would get plus 27. So what you end up with is negative x minus 6 to the second plus 27. That's kind of out of room of my graph, which is okay. I'm going to just kind of talk through how you do the graph anyway, so I'm not going to do the graph accurately. Okay, tell me what the vertex is. 627, okay. Okay, so it's 627. The transformations, what are they? What does the 6 do? Right 6. What does the 27 do? Up 27. Okay, so you've got right 6 and then up 27. Axis of symmetry is just x equals 6. Okay, so once you get it in that form, you got it made. Now, okay, my graph didn't go up to 27, so let's just kind of wing it here. Just go over 6 and pretend like that's 27, okay? And that's good enough. But you would still do the same thing. You would still go, it's opening downward, so you would still go over 1, down 1, and so forth like that. I'm not going to worry about a real accurate graph on that particular one if we go like that, okay? I think this kind of problem is one of the reasons why students don't like to complete the square, because there can be mistakes in that if you're not paying really close attention. Yes?
So what is the other ways to do the problem? Factor by grouping?
No, I'm getting ready to show you, you can always find the vertex by doing negative b over 2a.
Okay.
That's how you get the x value. And then once you find the x value, you can plug it into the function to get y.
To get the y.
Yeah, that's probably what most students end up doing, okay? But it's good to know both methods when you do this. Completing the square sometimes can be kind of tedious, particularly if you have fractions and stuff. So is there any question what I did on that problem? That one's kind of tricky with the negative, okay? Okay, now I'm going to teach you the other way to do it, okay? And you'll see if you like this way better. I don't know. All right, so here's the idea. If your quadratic function, if it's in standard form, like ax squared plus bx plus c, then you can leave it in that standard form, and then you don't have to worry about completing the square to put it in the vertex form. So what you do is the vertex, the x value of the vertex is negative b over 2a. And that just comes from the quadratic formula. And you don't need to write this out, but just to point this out, is that's the quadratic formula. And it turns out if this thing right here goes to 0, then that gives the x value of the vertex. Okay, that's where that comes from. So in this particular problem, I'm going to take this example. We have negative x squared minus 2x minus 5. Well, you just identify what everything is. A is negative 1. B is negative 2. And then C is negative 5. So if it's in the multiplied out form of the quadratic, you just do that. Okay, then what you want to do is you want to just do negative b over 2a. All right, so you're going to do negative 2. You have to do the opposite of b. Then you do 2 times a, or 2 times negative 1. And that'll automatically give you the x value of the vertex. So that is 2 over negative 2. So that's negative 1. Okay, so on our answer, see, we've already got negative 1 is the x value of our vertex. Okay, that's real simple to do. Okay, negative b over 2a. Now what you want to do from here is you just want to find what y is. And the way you find y is you just do this. You just evaluate the function at negative 1. So if the vertex has an x value -1, then just plug -1 into your function and calculate. So that would be -1 squared minus 2 times -1 minus 5. Okay, like that. And then just crunch out the details. Be real careful about this part right here, though. That's -1 squared is 1, but then the negative reattaches to give -1. Okay, so it's just the opposite of -1 squared. And then this part right here would be positive because you're multiplying two negatives. So we'd end up having 1 minus 5 or -4. So that's your vertex right there. Okay, to me that's a little bit simpler. What do you think?
Yeah, I like that better.
Okay, students usually do. I mean, it's to me it's the same amount of work. It's just arithmetic, though. You turn finding the vertex into an arithmetic problem. Okay, now if you were to look at this, does this parabola that I'm highlighting in blue, does that open up or down? Opens down, right? So if it opens down, would that vertex be a maximum or a minimum? It'd be a maximum, right? Okay, so that would be what we call a relative max, and that's just because it opens down. Okay, so you can always tell if it opens up or down by the number in front of that x squared term. So that's how you can do these problems with alternative methods. See, this number 5, the completing the square would be a little more difficult, so it's just as well to just go through and do -b over 2a and be done with it. Okay, any questions about what I just did? Okay, all right, so let's run through one of these together here. So see, that's already in the standard form. So again, what you have here is you have a is 5, you have b is 10, and then you have c is -7. So we're just going to crunch out -b over 2a. Okay, so let's go ahead and just do that together. Okay, so we would have -10, b is 10, 2 times 5, a is 5. So it looks like we have -10 over 10, so that's -1. So the vertex has an x value of -1. Okay, so that's how you start. Now, what do you do to find the y value of the vertex? What do you do with the -1? Just plug it in, okay? All right, so what you do now is you do f of -1. So just take the function I gave you in the order it is, just plug in -1 everywhere you see an x, and then perform the arithmetic. So if you do it this way, you're just doing arithmetic. You don't have to worry about the algebra and completing the square. So this is going to be 5 times 1 minus 10 minus 7. So that looks like 5 minus 10 minus 7. So what is that? -12, I think, is what that is. Okay, so that means the vertex is going to be the point -1, -12. Okay? Does that make sense? Okay, now you can do this either way. I think that if I usually complete the square because I can do it pretty quickly. But if completing the square is more complicated, then this is the way to go. So it's good to be flexible when you do that. Okay, so now what happens is axis of symmetry is just going to be x equals -1. The transformations go like this basically. So what would happen on this is if you put it in standard form, you would end up kind of having this. Now this is not the standard form of it, but you would have x plus 1 squared minus 12, but then you would have some value of a, but we don't need to know what that is necessarily in this problem. Okay, so what I'm going to do then is it just looks like we have a left 1 transformation, and then we have a down 2 transformation. That's what the vertex tells us, is we're going left 1, and then we're going down 12. Okay, so what we'll do with this one is this basically. We'll go through and plot the point. So we got the vertex is -1, -12. And then what happens on this one is you're going to end up having a is 5 on this problem. So let me kind of explain that. So if you're going to do the problem this way, if you were, and I'm not going to finish completing the square, I'm just going to kind of tell you what would happen on this so you can determine what a is. Okay, but if you did completing the square on this, you would have to pull the 5 out, and then you would have 5 times x squared plus 10x, not 10x, plus 2x. So I'm taking the factor out there. And I'm not going to finish this, but the key thing to understand is that a would be equal to 5. So you could no longer go over 1 up 1 and over 2 up 4. Okay, you can't do that anymore. So actually what you have to do is you got to do this. And you can write this down if you want to. You would go over 1, but then you would go up 5 times 1 to the second. Okay, because that 5 is just changing that up 1 to 5. So what you would actually have to do is just go over 1 up 5. Okay, if that was a 4, then it would be up 4, and so forth. Okay, does that make sense? Okay, so from here, just go over 1, and then 1, 2, 3, 4, 5. So I think you're at that point right there. And then you can get the symmetric point. And then all we're doing on these is just doing rough sketches. So if you get a couple of points, that's good. And the other thing is, I want to just mention this. If you went over 2, then what would you do? You would go up 5 times 2 to the second. So that would be 5 times 4, so that would be 20. So you would also go over 2 up 20. Okay, so that you got to figure out what A is to figure out how to get those points. Does that make sense to you? Okay, does the over 1 up 1, over 2 up 4, over 3 up 9 make sense where that comes from? Yeah, it's a squaring function, so we're going up a perfect square. And then that stretch shrink is just changing that value, in this case by a factor of 5. So that's how you do that, okay? All right, and you can figure out A is always going to be the number in front of x squared, okay? And that'll kind of help you get that put together. Okay, so let's see. I'm going to do a couple of others like this. I think I'm gonna do this number 6, and then I'll let you all maybe try number 7 to kind of see if you can absorb this okay. So what I'm going to do with this example is let's go ahead and just crunch out the vertex. So what we have is we have f of x equals x squared minus 2x. So again, what we'd have is a would be 1, b would be negative 2. What is c in this problem? Even though it doesn't matter, it's 0. You don't even have to worry about what c is. Finding the vertex has nothing to do with c. Okay, so what we'll do is we'll just do when we find the vertex, we just do negative b over 2a. Okay, so b is negative 2, so we would have negative 2 over 2 times 1. Okay, that would give, it looks like 2 over 2. So that's equal to 1. So the vertex has a x value of 1. Okay. All right, and then what we got to do is find the y value. So the y value, you do f of 1. So you're just taking the 1 and plugging it in to your function. So you just do 1 squared minus 2 times 1. That'll give you the y value. So that looks like 1 minus 2. So that's negative 1. Okay, so that's the key thing on a parabola is to get the vertex. And either that's going to be a max or a min, depending on whether the parabola opens up or down. Okay, so what is the axis of symmetry? X equals 1. Okay, that's always x equals whatever the x value is. So we have that. Okay, does this parabola open up or down? Up. Okay. So now what we're going to do is just kind of sketch a graph. Now I'm going to have you on this one just kind of, just make a few points, okay? We're going to plot the vertex, and then we'll just kind of freehand it the old-fashioned way here. All right, so let's see. We're going to plot the vertex. The vertex is over 1, down 1. Okay, now in this problem, see, a is 1. So that means you're going to go over 1, up 1, over 2, up 4, and so forth. Okay? So that just means since a is 1, then you'll just go over 1, up 1, and over 2, up 2 squared, or 4, and that's good enough. Okay? Then you got it. Okay, so I'm just do that. Over 1, up 1, left 1, up 1, over 2, and then up 1, 2, 3, 4. So you would end up having a graph that kind of looks like this then, okay? So you got a nice accurate graph by doing that, right? Okay, so let's look at this. Now, how about increases? Where does this function increase from? Where to where? Use x values too. We've learned this. So from where to where? Where does it increase?
X greater than 1.
1 to infinity, right. Okay, this part right here, I'll highlight that part right there is increasing, right? Graph's getting bigger, okay? So what we have on this is it increases from 1 to infinity. I always use open, and I think our textbook, I found out, has been using brackets on my math lab. Is that right? Which I don't agree with. I don't agree with that at all. But I'm going to use an open there. But on tests and stuff, I'm not going to fuss about that issue at all because of the ambiguity of the way our textbook is doing it. So I'll go bracket or parenthesis either way. When calculus, you're going to probably, calculus books that I'm familiar with are going to have a parenthesis on it. And then decreasing would be from negative infinity to 1, like that, okay? And then, of course, you would have a minimum. So you don't have a maximum. So your relative minimum, you usually, and this kind of depends, you can write a minimum however you want to. A lot of times the standard way is to tell me what the y value is, but you can also say give me that point if you want to. Like on an exam, I'm going to tell you give me the y value of the relative minimum or give the point. So I'll direct you through that, okay? That's the idea. Okay, so one other thing we want to do is the intercepts. The intercepts are obvious from the graph. So what we'd have on this is I'm going to go ahead and just do this kind of at the side. We've learned how to do x-intercepts. Let's do this algebraically, even though you can tell by looking at the graph. So remember what you do to get an x-intercept is you set f of x equal to 0, okay, like that. So go back to the original function, which is x squared minus 2x, and set that equal to 0, okay? So what we do is solve that by factoring, okay? This is kind of what we did in the last section, so you can factor an x out. Okay, if you do that, then what are your two x-intercepts? 0 and what? 2. 0 and 2, good, okay? And that, you can look at the graph we drew, and you can tell that's right. So we'll just say x-intercepts, we'll just say x equals 0, comma 2. That's good enough. You can just tell me what the x values are. The y-intercept on here is also y equals 0. And the way you do a y-intercept is you set x equal to 0. So if you take your function, you're just doing f of 0. So that's 0 squared minus 2 times 0. So that's equal to 0. Okay, and that's it. Okay? So that's how you want to kind of do those problems with the negative b over 2a way. And to me, it's probably a little bit simpler for students in the long run. And then if you do x-intercepts and y-intercepts, you just kind of work with the initial form, okay? All right, well, I'm going to let you guys go ahead and work on 7 yourself, and you can compare some answers on this, then we'll take a break. So I'll let you work on this for a few minutes and see how you do. I'm going to leave the screen up here if you need to get this copied down. Then I'm just going to shut it off for a minute, and I'm going to work it out, and then when we're ready to check, we'll all check, okay? But go for it and see if you know what's going on, okay? What's your vertex? Negative 3, 4. Okay, what's your axis of symmetry? X equals negative 3. Parabola open up or down? Down. Okay. How about your X-Intercepts? That's the part of the problem when I was working out that I thought some students might have trouble with the factoring. What's your X-Intercepts?
-5, 0, -1, 0.
Yeah, negative 5 and negative 1. And how about the Y-intercept? Negative 5. Okay. Now I'm going to put this up here and let you look up here and see what you got. The thing is, you want to make sure, of course, you got the vertex first. So I'll run through this and we'll take a break here. So when you do negative b over 2a, you would do negative negative 6 over 2 times negative 1. So you would end up getting negative 3 for the x value of your vertex if you did the arithmetic right. Okay. Then you got to plug in negative 3 into your function, and it's all about arithmetic. So if you plug in negative 3 into your vertex, you would have got 4. Okay, and that's the key, because if you don't get that, that messes everything up. All right. Okay. Now what I was kind of looking on here was the x-intercept. Let me show you kind of what I did. So you take the function that I gave you, negative x squared minus 6x minus 5, 0. What I usually will tell a student, this is the way I do it, if I have a negative number in front of x squared, I like to make it positive because I think factoring is easier. Now you don't have to do this, but I do think it makes it easier. So I just divided both sides by negative 1, and that changed this to x squared plus 6x plus 5 is 0. And factoring's a tad bit easier. So if you factor that, you'd have x plus 5, x plus 1. So those are your two x-intercepts. Now you could have figured out the x-intercepts by counting out the over 1 down 1, over 2 down 4. It would have worked that way, but you don't want to rely on that because a lot of times your x-intercepts will be things you have to do the quadratic formula on. You have square roots and stuff. So counting will work sometimes, but most of the time it won't. Then the y-intercept is just replacing all the x's with 0 to get negative 5. And then you can see my graph, and then you would increase from negative infinity to negative 3. Then you would decrease from negative 3 to infinity. Okay, like that. Okay? Now let's go ahead and take, let's see what time it is here. Let's go ahead and take a break. I'll start back, I think, at 9:10. I'll leave that up there and let you finish that up, and let me know if you have any questions on that. Calculator. Okay, so first of all, this problem number 8 is you're not graphing or anything. You're just telling, does it have a relative max or min? Okay, so first of all, how would you tell if it has a max or min? Well, you just answer the question, is the parabola opening up or down? So on number 8, is it opening up or down? Up, okay. That number is positive, so it's opening up, so that means that you have a minimum. Okay, so we're just going to find what that minimum is, all right? Well, the way to do this is just the negative b over 2a, and all I'm going to do on this is just find the vertex again. So a is 5, b is 5, c is not there, so it's 0. Remember, c doesn't have any bearing on the vertex anyway. So if I do negative b over 2a, I'm going to get negative 5 over 2 times 5. Okay, so that's negative 5 over 10. So that reduces to negative 1/2. Okay, so you can have, of course, a fractional value when you're working out your vertex then, okay? Now what I'm going to do is just over at the side, I'm going to do the arithmetic to find the y value. So I'm going to do f of negative 1/2, and I'm going to deal with the fraction. You can't get rid of it, you just deal with it. So I'm going to have 5 times negative 1 to the second plus 5 times negative 1/2, okay? You could do some things on the calculator to check. I want to go through and just do this the old-fashioned way here. So if I do negative 1/2 times negative 1/2, that'll give me 1/4 when you square that. 1/2 times 1/2 is 1/4. And then over here we'd have minus 1/2 like that. Okay, when you multiply fractions, you multiply straight across, so that's going to be 5 over 4. Did the teacher do something unnecessary or what? Oh, I forgot the 5. Thank you. Okay, I was just talking to you about not getting enough sleep. That's my excuse. All right, so that's negative 5 halves. Okay. Thank you. Okay, that has to be multiplied by 5, so that would be negative 5 over 2. Now we're in good shape. Okay, so what I got to do now is I got to get a common denominator, which is 4. So I multiply this by 2 over 2 to introduce that common denominator. Okay, so that's going to end up giving me 5 over 4 minus 10 over 4. So that looks like negative 5 over 4. Okay, that's the old-fashioned way of doing that. You want to know how to do fractions by hand, but you know, you can do this on your graphing calculator. I'm going to show this to you one more time because it sure is nice to know how to do a lot of stuff with your calculator to check and verify stuff. So I could actually just go like this. I could go 5 times, I could even do negative 0.5 squared. Just, you know, replace the 1/2 with negative 0.5, and then it would be plus 5 times negative 0.5. Now see, that would give me a decimal, negative 1.25. Well, if I go to the fraction, you can go to math, and then convert back to a fraction. Okay, so that's the lazy man's approach. Okay, so it's negative 5/4, but you want to know how to do that in the modern world. These calculators do fractions, so check and verify everything you do. Okay, all right. So what we'd end up having on this is we have the vertex, and then we know that that is a minimum. Okay. Okay, the next couple of problems, you want to get your calculator out and try to do this along with me here. And with these things, I'm just giving you some functions. You don't really need to worry about where the function comes from. A lot of you are going to go on probably and take physics maybe like next semester or something. Physics 1. If you're going through the calculus sequence, and if you're in engineering, you'll probably take calculus-based physics. So a lot of times you take that with Calc 1 or Calc 2. So you'll learn about these projectile motion equations and so forth. So what we're going to do is, this is a projectile motion equation. All this stuff here is just telling you what it represents. This 100 is the initial height of the object. The 45 just means the projectile's fired at a 45-degree angle, and it has a velocity of 210. Don't worry about where that comes from. That's not what we do in this class. So what we're going to do is just put this in our calculator. So what you want to do is go to Y1, just put that in. Now, I typed on your notes, you know, how you would put that in. Be sure you use your parenthesis keys correctly and everything. So general rule of thumb, anytime you put a fraction in your calculator, have the numerator in parentheses and the denominator. If you do that, you aren't going to go wrong. Okay, there's times when you can leave that off, but it's pretty important in this case. And you could leave the parentheses off the bottom and just put 210 to the second like that. So that will take care of that. And then I have what? I have a plus x. And then I have a plus 100. That 100 is the initial height of the object. Now what you want to do is do a window. I went ahead and figured out a window just kind of by playing with it. But again, what I see is since the initial height is 100, that means my y max has to be bigger than 100. So I mean the projectile's coming up. You have a parabola opening downward because you have a negative 32x squared. So just put in the window that I gave you here. So we're going to go 0 to 1500. And I just kind of experimented until I wanted to see the whole parabola. That's kind of was my idea. Then I scale that by 500. And then on the y's, I'm going to go 0 to 600. And then scale by 100. Okay, and then what you'll have on this is you'll have a quadratic function like we learned how to do, but this is more of a calculator problem. But you wouldn't want to complete the square and find the vertex and all that stuff on this problem. You'd want to use technology. So if you graph that, we should have this. And what we're going to do on this is it says how far from the base of the cliff is the height of projectile a maximum. Okay, so I'm going to move this little picture over here. You don't need to sketch this out necessarily unless you want to. But what we're looking at here is this is your maximum right there. Now you could do negative b over 2a to find what that max is, but to me this is a technology problem. So the question is how far is this from the base of the cliff? So really all you got to do is you just got to find that x value of the maximum, and then that would be the distance that is from the starting point. Does that make sense? Okay, all right, so that's what that is. So the way you do the maximum is like this, and you can write down the keystrokes if you need to. We've done this several times before. So what you do is you go, once you get your graph, you go second trace to open up the calc menu. Since we're doing a max, you want to go to option 4, and then you want to get your left and right bounds. Okay, so we do this. Okay, get a left bound. Okay, so I'll just move a little bit to the left of the vertex, and then press enter. Then I move a little bit to the right of the vertex to get a right bound. Okay, and then it'll come up and say guess, and when it says guess like this, just press enter. You're just getting bounds, the vertexes between those two bounds, and then the answer should pop out. Okay, so what I get is this point right here, the vertex is the point 689. I'm just going to round it like that, and then I'll say 444.5. Okay, so that's what that is. So what you'd end up getting is the answer of the problem would just be 689 feet from the base of the cliff. Okay, that's the idea. All right, so see, if you're a calculus student, you learn how to do a derivative and find what's called a critical value, and you use that to find maximums and minimums. So you'll revisit this in a calculus class using calculus. Okay, does that make sense what I did? Okay, so everybody following how to do that on the calculator? Okay, all right, okay, all right. So, and this is the kind of thing I do on the calculator part of an exam. So probably like your exam too, I might have something similar to this where you're finding a max or a min. Okay, you have to have your calculator to do that. Okay, all right, let's do this next one here, and then that'll finish this up. This one is more like economics. So you've got a cost function, which is quadratic. And what we're doing on this is, let's see, X is the number of videos rented daily, and C would be the cost in dollars, it looks like. So we're going to find the lowest cost to the nearest dollar. Well, why the lowest cost? Well, okay, this is a quadratic. Does this quadratic have a minimum or a maximum just by looking at it? Yeah, how do you know it's minimum? Because it opens up. That's why it's a minimum problem. We're looking at a lowest cost, okay? So let's just put this in the calculator, and we'll do the same thing, except this time we're finding a minimum. Okay, so you want to just wipe out what you did on the last problem and then put in this function. So that is 2x squared minus 30x, and then plus 560. And then, whoops, then put in the window I gave you. So I just outside of class played with it a little bit and got a maximum, or got a window. One thing that helps me on this, and this is something you want to know, is that number right there is the y-intercept. Okay, so that means my graph has to go way up high on the y-axis. That's why I made that probably 800, is so I could see that y-intercept. Okay, so put this in. Let's see, the window I gave you was 0 to 20 by a scale of 5, and then 0 to 800 by a scale of 100. Okay, so if you get everything put in, you should have a parabola that looks like that, kind of, that has a minimum. So then we're going to just find that minimum value. Okay. All right, so doing that, you just do basically the same thing. Just go second trace. Then this time you do a minimum, so you do option 3. And then you do the same thing with the bounds. Okay, get a left bound, so make sure they're to the left of the vertex. Okay, get a right bound, make sure you get to the right of that. And then when it says guess, press enter. Then out should pop your minimum, okay, like this, okay? So what I would have here is, it looks like, let's see, there we go, about 7.5. So on my graph, I'm just going to move my graph over here. You can draw just a real rough sketch. It doesn't have to be perfect. So the key thing that I want to see on this is that the minimum on here is the point 7.5 and then 447.5. That's your minimum right there. So that means that you're finding the lowest cost to the nearest dollar. So that would be the lowest cost is going to be the Y value. So that will be $447.50. Okay, that's what that is. Okay, all right. Any question with the technology portion here? Okay, does everybody have a good graphing calculator for Wednesday's exam? Okay, all right. I know a lot of students this semester who don't have like calculators, not doing homework. Yeah. Are you getting something different than I got?
No, same thing as my distance. My distance is 448. So I'm just wondering if there's any difference in the exam.
I'll tell you what to round to. Okay. Generally, I'm going to just specify. If I don't specify, then it doesn't matter. Okay, but I usually try to specify round to 1 decimal or whatever. Okay. Okay, any questions? Okay, yes.
I'm having a hard time zooming out. Like it's only letting me go to 10.
Okay, you probably just need to reset the window. Now you can do that.
I'm going to see you during office hours also. I think this is best for
you got something going on there? Or you can ask me maybe right after class if you got a minute and I can take a look at it. But one of the things I tell students to stay away from zoom in, zoom out and just set windows. There's several things that you can do on there.
Yeah, you got to set the X max and the X min.
Yeah, I just kind of state that zoom in, zoom out can kind of be helpful for you to figure out a good window for you to put in, but I recommend you just put a window in. Okay, seriously. You want to know how to do that anyway.